You're here because you want to learn about alkanes with a University of Cambridge graduate. Hi, I'm Brendan, and I'm a University of Cambridge graduate who has been teaching chemistry to many students like you over the past 9 years. I'm also the founder of the Chemistry Institution, where we have helped many students improve in a short amount of time and achieve the grades of their dreams. Be sure to check out our website in the link in the description below so that you can download a free copy of the notes for yourself and use it to run through this lecture with me today. Now that we have finished Introduction to Organic Chemistry, it's time to move on to specific functional groups. We'll start with alkanes. Alkanes have a general formula of CnH2n plus 2. Now you must memorize this because it's very highly tested during your exams and when you have to answer the specific general formula for a homologous series of alkanes. These are saturated hydrocarbons, meaning they only have single bonds. And usually it only contains of carbon and hydrogen inside. And it's good to know that alkanes are also relatively unreactive for two main reasons. One, they are non-polar, so they have no point of electron-rich or electron-poor sites, making them very unreactive because electron-rich or electron-poor species tend to have an easier time. And second, the carbon-carbon bond or the carbon-hydrogen single bond are relatively strong. So you need a relatively larger amount of energy to start any reaction, making them quite unreactive. For every functional group, it's important to know the chemical reactions. For alkanes, one of the reactions they mainly go through is combustion. Combustion is a reaction that most organic compounds would undergo because it just requires burning under excess oxygen to produce CO2 and H2O because they're mainly comprised of carbon and hydrogen. But take note, sometimes incomplete combustion can happen. In those cases, you would produce either carbon monoxide or sometimes soot. So for example, if you have ethane under complete combustion, you have to balance the equation and know that CO2 and H2O are being produced. When this is all balanced properly, can you further answer questions related to combustion? Do take note that combustion is usually tested in mole concept, and it's a good way to combine organic chemistry with mole concept as well. Another reaction that alkanes typically go through is a substitution reaction. The name of this reaction is specifically free radical substitution. This is a reaction where the hydrogen atom of the organic compound is being replaced by an atom of a halogen, like bromine or usually chlorine. This is catalyzed by UV light or sunlight, which is important for you to know because you need to know about reagents and conditions for specific reactions for a functional group. This is also typically a chain reaction that leads to a variety of different products. The reason behind this is because radicals are very reactive and will just react in any unpredictable fashion. So here are some examples of the reactions, and we're going to draw out the bonds to clearly show you the substitution taking place. For CH4 plus Cl2, there's this substitution reaction that occurs. If we draw this out, you can see that with this, one of the hydrogens is going to be replaced by a chlorine, as circled over here. And don't forget, there is a byproduct that will come out of this reaction as well. Another reaction that we can showcase this is CH4 as well, but this time with 2Cl2. And because radicals, which is what these chlorine will become under UV light, are very reactive, they can actually be di-substituted as well, or even tri-substituted. Hence, the reaction is actually very unpredictable, and we never know what kind of product we are getting. Alkanes can also undergo this reaction called cracking. This is a process where hydrocarbons of high molecular mass are broken down into smaller hydrocarbons of lower molecular mass. These usually give a mixture of products under different conditions. Example, varying the temperature and the catalyst. For your sake, you just have to memorize that the reagent condition for this reaction is aluminium oxide as a catalyst and 600 degrees Celsius. In your syllabus, it's also important to know the importance of cracking. You need to know why you need this reaction industrially. One, you need to meet the higher demands for shorter hydrocarbons. For example, your high-grade octanes used as fuels for motor vehicles are produced by cracking itself. For example, if you crack C18H38, a very large hydrocarbon, you can get this C8H18, which is the high-grade octane for the reaction or for the fuel for your motor vehicles. Another reason why it's important is because it can produce your shorter chain alkenes. For example, your ethene, which is typically used to make polyethylene in your plastic bags. Or it can be used to make ethanol as well. So for example, C18H38, if you crack it, you can also get C2H4 from the reaction as well. And final reason is you can also get hydrogen gas from this cracking reaction too. Hydrogen gas is important because it can be used for the manufacture of ammonia in the Haber process. So the C18H38 can also crack to form H2. Because of the variety of different products, cracking is actually a very useful reaction industrially to produce these 3 different products that can be further used for its own purposes. That's all for today's video. If you really learned something and you like this video, be sure to click on that like and that subscribe button so you don't miss out on free content like this. If you want to join my community of students at the Cambridge Institution, be sure to check out our link in the description below so that you can sign up for a free trial class today. Here you can learn the exact systems that we use at the Cambridge Institution to help our students improve in a short span of time and also achieve their grades of their dreams in the end.